Welcome to the Tech Study channel. In this is the third video, fourth part. So in the first part, I have explained data model, data relation, data semantics, consistency constraints, types of data models, hierarchical and network data models. So and mapping coordinates of data model. So here in the first part I have explained all these concepts, and in the second part I have explained relational data model, relationship types means mapping coordinates, and in the third part NoSQL data model I have explained, and in this fourth video I will explain now object data. In this video I will explain object based data model. So first we will see what is data model, data, and then data relation, data semantics, and consistency constraints, and then object based data model, features of object oriented programming, and example of object based data model, and querying this example. So first, what is data model? Data model are visual maps or blueprints that describes how the data is organized and stored and how related to other data. Here these are the imaginary blueprints which describes the how data is organized and stored and how related to other data. Data models are conceptual tools for describing data, data relation, data semantics, consistency constraints. So what is data means? A collection of raw unorganized facts and figures that can be processed to produce meaningful information. So these are some important questions of DBMS. So half answer is more than half data models are completed. Data model so I am explaining in this video the one type of data model, which is object based data model. Okay, so here collection of raw unorganized facts and figures that can be processed to produce meaningful information. Meaning raw unorganized data means standalone unlinked contextual data. Example, numbers, text. Numbers like 90, 85, 95, 12, any number, that is undistributed list. And text, apple, red, Hyderabad, any random word. Okay, and here uncontextualizing means according to any topic organizing the text data. So uncontextualizing means we are not Organizing the data according to a particular topic. It is chosen from multiple topics. Then processed data, linking and contextualizing, analyzing data so data makes sense and has meaning, it becomes information. Example, processing a student's unorganized monthly test scores results in calculated averages, percentages, ranking and pass or fail grades. Here unorganized monthly test scores are raw data, raw or unorganized data, and also called unprocessed data. And the averages pieces of and averages, percentage, ranking, pass or fail are processed data. So, and then another example is scanning a product barcode, processes unorganized item numbers and prices into a itemized customer receipt with tag and grand totals. Here the number of items and prices are unprocessed data, means raw and unorganized data, and tags and grand totals are processed data. Then related data, how pieces of data connect to one another logically within the system. Example, customer's name, their purchase history, skipping addresses. So customer name, purchase history, skipping addresses are the pieces of data here. The relation between processed data and related data is, so processed data helps to find relation between different types of data. And then we will see what is data relation. The data relation, second topic. A table that stores data in a structured format. Data relation is a table, okay, that stores data in a structured format. And then data semantics. Data semantics refers to meaning and interpretation of data rather than just its physical storage or structure. So meaning of the data and interpretation of the data. Interpretation of data means the database management system reads the user's request, checks for syntax errors, validates table or file names, and translate it into an internal mathematical structure. Usually relational algebra is the first phase a query goes through before it is executed. This is the before execution process. Reads the user request, checks syntax errors, validates table or file names, and translate it into an internal mathematical structure. Okay, and then it defines what the data represents in the real world. Examples: employee, department, product. It ensures columns store the intended information such as defining data types, setting default values, or applying constraints. Example, age column can't be negative. How different entities connect and interact. Example, employee is assigned to a department. Employee and department are entities, and assigned to is a relation. relationship. An entity can be physical or logical, and logical is also called conceptual. So here two types of entities I have shown here. Why? Because this helps to create entities by our own. Okay. Tangible, physical. Tangible or physical things we can touch. Employ, car, product, building. And then intangible. Intangible, logical or conceptual entity. Concepts or events. Okay, these are the concepts or events. Example, conference, department, project, bank account. And example entities, example diagram for data model is OpenSlava conference. It is an entity which is represented by rectangle, and relationship is represented by diamond or rhombus. OpenSlava conference hosts by manager 2. OpenSlava conference type is tech conference, and OpenSlava conference hosted by manager 1, and manager 2 works at X company, manager 1 works at Z company. Z company have same interest as X company. We can consider same interest while buying products, okay, of their respective company needed products. So they take the same interest. That's the relation, and these are the relations, and these are the entities. Okay, and then consistency constraints. Consistency is a word, means consistency constraints is not a proper word, but consistency is achieved by you following the constraints. So we have named that like consistency constraints. So consistency is the actual state of database. It means that the database accurately follows all those predefined integrity constraints after any transaction, query, concurrency, etc. completes. This is the actual state of database. Database accurately follows all those predefined integrity constraints. That's why it will become consistent. Okay. So after any transaction means set of operations performed on data items. Data items like account A and account B, we can consider two data items. So transferring money from A to B is an transferring money from A to B is an one transaction example. Then query, inserting, updating, anything, storing, managing data into the database from the database. It's called querying. And concurrency. Concurrency means simultaneous execution of transactions effectively. And then what are the integrity constraints? So integrity constraints, a set of automated rules in a database to ensure that data remains accurate, consistent and reliable. So set of rules to ensure the database remains accurate, consistent Accurate means up to the mark and consistent and reliable, trustable. And they act as a safeguards to block invalid information from being added or modified, ensuring data quality across the entire system. These are some types of constraints: domain constraint, entity constraint, referential constraint, no-null constraint, check constraints. So defining the type of domain. So age, example, age positive number only. Domain is nothing but, if we consider a table, it has columns. Okay, it has column names. So domain is a set of values that a particular value accepts, okay, to enter into a particular column. So like example, integer, varchar, integer for numbers and varchar for text. Okay, so if we define domain, then we can insert related any format of data, any text or numbers, etc. And then entity constraints must be unique row using primary key. And referential constraints maintain logical relationship between tables, between two tables, using primary key and for region key. Means consider two tables, student table and course table. It has the student name and student ID. Two columns are there, and it has a course name and course ID. So if course ID and student ID values in these two tables are same, then we can make a student ID as primary key and course ID as for region key. So these two tables will become related to each other. Logical relationship will be developed. So then no null constraints. Specific column can't be empty when a new entry is created. And check constraints. Enter data meets a custom logical condition. So example is, if we want to create a table with a we are creating a table with condition. So table is like a employee table. Okay, employee ID, employee name and employee salary is there. 3 columns are there. We have created this table with a condition, that is salary greater than 25,000. So then if we want to insert the row into this table, then I have to provide a serial number, that is anything 5, and then employee name XYZ and salary 24,000. Then it will not accept. It shows 0 rows are inserted because the condition is not satisfied here. If I give 25,000 to 26,000, then it will accept it. Okay, 1 row will be inserted. We can see on the table, in the table. Okay, and then integrity constraints completed, and then it describes the data model describes the design of database at each level of data abstraction. These are These are the levels of data abstraction: external level, conceptual level, which is also called logical level, and physical level. So this data model describes the design of each level. Okay, how the data is related, and what data is present, and relationship between them. So it describes that. Okay, and then it acts as a bridge between real world business and the actual database. And so now we are discussing object based data model. So here it is. Object-based data model is a database model that stores data as objects instead of tables. Okay, it combines the features of object-oriented programming (OOP) with the core functions of a relational database. So, what is relational database? Yeah. Here, relational database stores information in the tables made up of rows and columns in structured data format. Okay. And what is object oriented programming means is a way of writing code that organizes software design around object. Data structures the data structures that represent real world things rather than just functions and logic. Object oriented programming in DBMS, it means that the way of writing code that organizes software design around objects, data structures that represents real world things rather than just functions and logic. So what is object here means? So here object in the DBMS, it means any defined structure in a database that holds, organizes or references data. It has three parts. So any defined structure in the database. Database is what? The collection of organized data. The database is the organized collection of related data. And related data means how they are related to, or the pieces of data is related to each other. That is called related data. And database is a organized collection of related data. And here object any defined structure in a database that holds, organizes or references data. It has three parts: identity, a unique ID that distinguishes it from other objects. Okay. And then it is given by system to a specific instance, like a student, a car, a bike. The system will give a specific number to it. Okay. That's the identity. And example, Aadhaar number for each citizen. Okay, and then attribute. Second part is attribute. Second part of the object is attribute. The properties of object is called attributes. If student is entity, then attribute is equals to age, class, female or male, marks, etc. Then methods of the object, the actions, functions the object can perform. Okay, so entity we already know, so I'm differentiating here entity and a object. Okay, so entity we already know, a real world thing about which we want to give information. So an entity is a data part contained inside an object, and the type of object is indicated by entity. So we understand these two statements by using example. So entity, bank account. Bank account, it is the abstract concept of a bank account containing a balance. Okay, containing a balance. And the object, an active digital instance of a bank account in an object oriented database. It contains the data balance 500 plus the built-in code or methods to run actions like deposit or withdraw. The entity only contains balance, but the object contains balance plus deposit or withdraw functions. That's the main difference. Okay, here we are saying entity is a data part contained inside the an object. So why? Because only balance is there in the entity. And then entity are conceptual, means imaginary. Okay, what we draw on a whiteboard. Objects are technical, what we actually create in computer's memory or database. And then you are here. Okay, so object oriented programming is a way of writing code that organizes software design around object. Okay, and data structures that represents real world things rather than just functions and logic. So objects means data structures. Okay, in the database. And instead of writing a long list of instructions for a computer to follow step by step, we create objects that handle together data. Okay, what they are, and behavior means methods, what they do. Instead of giving list, we are creating objects. Okay, to handle the data in this object based data model. Then so here we have studied that it combines the features of object oriented programming with the core functions of a relational database. So what are the features of object oriented programming? We will see now. Features of object oriented programming: abstraction, polymorphism, inheritance and encapsulation. So abstraction. So here level of abstraction and abstraction both are same. used for hiding complex technical details. Okay, technical details. It ensures that the user should only see what they need without having to understand the complicated computer code or hardware behind it. Okay, and then it is often called the three schema architecture. Then so we can say three levels are there in the level of abstraction concept, or we can say there are three types of abstractions: external level, conceptual level, and another one is physical level. So first, external level, which is also called view level. It is higher level. It ensures users to see. It provide a simplified window into a database. Okay, it ensures users to see the window which is provided by it. Okay, so the purpose is it provides customized views for different users, hiding part of the database that aren't necessary for their specific tasks. So users will do any kind of tasks. So according to that task, it will give the customized views. Okay, for different users. An example: a sales manager only sees a customer's purchase, okay, history, while an HR manager sees the customer's payment details. Okay, means customer purchase history means mm, what are the dates he paid, okay, and the customer paid, and HR manager sees the customer's payment details, like account number and so on, like amount, account number, and name of the customer, like that. Okay, and if database logs a multi-layered architecture, if database so if database lacks a multi-layered architecture, making modification to the system, whether updating physical hardware or changing how data is viewed, becomes highly complex, time consuming, and error prone process. Because if it is not multi-layered, only a single layer will be present. So updating something physical hardware or changing how data is viewed will be complex only. The process will be complex because all will mix together. All the data in the different layers will mix together. So updating and changing are complex and errors may come. Okay, and then polymorphism. So the next feature of object oriented programming is polymorphism. Oh, no. I have said only first external level only. So the next level is conceptual level in the level of abstraction. Which is also called logical level. It is middle level. It describes what data is stored and how the different pieces of data is related to each other. So the purpose is to define overall structure or blueprint. Okay, like tables, columns, rules, relationships between tables. Okay, an example: defining that a customer table is linked with order table using customer ID. So order table is there and customer table is there. Here customer name and customer ID there, and order means product name and order ID is there. So these both tables are related to each other, linked to each other using customer ID. So in this case, customer ID is made as primary key, and here order ID is made as 4-region key. So these two columns values will be same for both tables. So that's why they are linked. But it does not care about hard drive. It cares about the logic, means how they are related. It does not care about hard drive. Means how they are stored, it does not care, but how logically they are related, it cares about. Okay, and then key is this is where the database administrator works. So database administrator means here database administrator, while the designer builds it, means the database, the DBA database administrator manages it daily to ensure it is fast, secure and always available. So what a database administrator do means, it will take copies of a database daily. Okay, modify it, and the tasks include granting or blocking user access, backing up data to prevent loss, and monitoring system performance. This second is possible because a DBA takes copies of database daily. Okay, that's why backup is possible. And then database administrator software that provides a visual interface for managing database servers, running administrative scripts and monitoring system resources. And this software is used by DB administrator, database administrator. Okay, and SQL Server Management Studio, SSMS for SQL Server, PG admin for PostgreSQL. So this software differs for each example of DBMS. So here DBMS examples are SQL Server and Postgre. For that it needs SQL Server Management Studio software and PG admin software respectively. Okay, and then so here, so this is where the database administrator works. So who is database administrator, I have explained now. And then physical view, which is also called storage view. It is lowest level. It describes how the data is actually stored in physical hardware, hard disk, SSDs. Its form of storage are file, indices, etc. Okay, purpose is to manage technical details like file path, data compression and indexing for speed and memory allocation also. how the data is related, in which format the data, the database data is related. Okay, so it will show by the physical view. Example, deciding the data should be stored in a specific file format or spread in multiple users to keep it safe. Okay, so spreading in multiple users means cloud servers, so through which any number of uh, users can access the data. Okay, and then key, this is handled by DBMS software and system engineers. Okay, and here is the university database example. Conceptual level is here we have three tables: student table, course table, and enrolled table. So it contains SID, any string, comma S name, any string, and CID, any string, comma C name, any string, and CID. It's a string is a data type. Okay, means domain of this column name. Okay, so SID string, S name string, CID string, C name string, CID string, and CID string. And then external view. So conceptual level means what? It shows the how the data is related and what data is present in this level. So student course, student table, course table, and enroll table present in the database in this level. Okay, and in external view, only if we want a course table, then we are querying it and then we access the course table. This is the example. And then physical schema. Physical schema example is means it is describes how the data is stored in the physical hardware. So relations are stored as unordered files. Okay, these relations: student, course, enrolled, tables. Tables are also called relations. We know that. So relations are stored as unordered files. These are stored as unordered files, and indices on first column of student. Index on first column of student. Here in this first column of student, we have a index. These are the diagrams. Okay, external level means users, view 1, view 2, view 3, user 1, user 2, user 3, and external conceptual mapping, conceptual level, conceptual physical mapping, and physical level, and database. Three schema architecture. That's why it is called three schema. We have three levels now. So, and then this is the more simplified example. That is it. It is a database which is a physical level, hard disk or SSD, and student table is there, and columns are student ID, student name, and project ID. This is the logical level, means how the data is related, and example is table, and external level a table, or we can say a column also. If in this level multiple tables will be there, then we can access one table. And if here in this case one table is there, so we can access a column, okay, in the external level. It only shows the related data that a particular user want, okay. And then abstraction concept is completed. Then polymorphism allows different data types of objects to be processed through a single interface. We already know what are objects. It's a structures in the database through a single interface. What is single interface? Is a unified generalized contract such as a shared method name, base class or abstract class. The different objects are used to execute their own specific behaviors. And means the object, the different objects to execute their own methods. Here behavior means methods. They use shared method names, means same method names, or base class or abstract class, okay. Here we have seen what is single interface. So here polymorphism allows different data types, objects, okay, to be processed through a single interface. Means different types of objects, different objects are executing their methods by sharing same method name, base class or abstract class. That's the meaning of polymorphism in the DBMS. And then where a single command means function, method or operation or data field means attribute adapts dynamically based on the specific type of data, object, number, text, etc. Okay, means functions are, here we are saying that functions are adapted according to a object, okay. If it is a car, then the function will be brake function, brake, like this, brake parenthesis. And if it is a radio, then radio id parenthesis. This will be the function, okay. So according to the object we are deciding the functions for it. And then in object oriented programming, the polymorphism in the DBMS I have defined here, and in the object oriented programming language I have defined here. So the polymorphism is the ability to the same command in their own unique ways. So here we have ability to execute, okay. Ability of object to execute same command in their own ways, okay. This is the definition, is the ability of the object to execute same command in their own unique ways. So here, method overloading. There are two types of polymorphism in the object-oriented programming. First is method overloading, having multiple methods in the same class with the same name but different inputs. Example, add int comma int versus add double comma double. So method name is same. Okay, means multiple methods have this same name in the same class. Okay, but different inputs. Here we have int and here we have double data types. And then another one is method overriding. A parent class provides a basic version of a methods, but the child class decides it needs something more specific, so it rewrites that method with the exact same name and parameters. Makes on parenthesis, makes on parenthesis. So if method overloading example will be, definition meaning will be like this. So one class is there, class A. So in this one method is there, add int comma int. Okay, and then some code is there, and another method is there but with other data types, means different parameters. So this is the meaning of the definition of method overloading. Okay, and then method overriding. Method overriding is a parent class provides a basic version of a method, but the child class decides it needs something more specific, so it rewrites that method with the exact same name and parameters. Makes on. Here it means class A is there. Okay, in this make sound bracket parenthesis some system dot out dot println statement is there, and here it closes the class A. Then class B extends A. Okay, this is the subclass, this is the superclass, means this is the parent class and this is the child class. Open bracket, make sound brackets, here it adds some other code, any system dot out dot println any variables. Okay, it can define. So both classes have same method name with parameters also. Okay, that is the meaning of method overriding. And then so what is the use in data DBMS? This polymorphism use. So polymorphism allows inquiries to handle different object types, saving account and checking account using a single generic instruction. So here is saying that allows queries to handle different object types like saving account and checking account using a single generic instruction. So what are saving account, checking account, and single generic instruction we will see now. So saving accounts, a bank account designed to be hold money, don't intend to use for daily expenses. Okay, it ends. So here it ends interest over time, but may limit number of withdrawals we can make in a month. Okay, then checking account, a bank account used for everyday transactions, writing checks, sweeping debit cards, paying bills. It allows frequent deposits and withdrawals, but usually ends little to no interest. Okay, and what is single generic instruction? Process account bracket account comma amount or withdraw 500. That applies to a general category rather than specific details. Okay, instead of writing separate code to withdraw money from a saving account and a checking account, we write one generic instruction. The system relies on polymorphism. Here, saving account and checking account both represents the objects. Okay, they are using same method name, that is withdraw. So that's why the system relies on polymorphism. When the generic instruction is sent to a saving account, the system automatically calculates and applies any saving specific rules, like checking withdrawal limits. And then when the exact same generic instruction is sent to a checking account, the system applies checking specific rules, like deducting a transaction fee. This approach saves developers from writing repetitive code. Okay, and then the third feature of object oriented programming is inheritance. In the DBMS, the definition will be a concept where a specialized entity subclass automatically receives the attributes and relationships of a more general entity, which is superclass. This allows we to model is a relationships, like a student is a person, without repeating common information in every table. So example is building a database for a university. We have many types of peoples, student, teachers, etc. Here I have taken student and teachers, but they all share basic information like name and email ID. So superclass means general table, whose name is person. Attributes are person ID, column, person ID, name and email. Okay, and subclass specific table, student and teacher. Two tables are there, student table and teacher table are there. And student inherits person ID, name, email and adds GPA and codes also. And teacher inherits person ID, name, email and adds salary and department. From where it inherits? From superclass, person entity, which is also called superclass, and student table and teacher table, which is also called subclasses. Okay, so instead of typing name and email into three different tables, we define them once in person table. Okay, the student and teacher tables only stores what them unique. which makes them unique. Okay, and then the fourth feature is encapsulation. In the DBMS, it is the process of bundling data and actions that operates on that data into a single unit. In the op- object oriented programming language, the encapsulation definition will be is the bundle of data only, but it contains objects as well. Okay, objects and some other variables and code are enclosed in a single unit, which is called class. So that's the definition of encapsulation in the object oriented programming language. So in the DBMS, is the process of handling is the process of bundling data and the actions that operates on the data into a single unit. We are bundling data as well as actions. Okay, this acts as a protective shield, restricting direct access to raw data and allowing modification only through controlled predefined interfaces, means methods. So in the class, in a particular class, modifications are allowed only by predefined interfaces, means methods. Okay, and encapsulation takes the table and hide them inside a protective layer. Instead of interacting with the table directly, users must use stored procedures, functions, or views to access or modify data. And then example is bank account database. So the data hidden, the raw account balance is locked away and can't be directly overwritten. Encapsulation means hiding. Okay, so the raw account balance is locked away and can't be directly overwritten. And the interface exposed. Instead of manually changing the balance, we provide two predefined actions: deposit of amount, and withdraw of amount. So these two avoids the manual changing. Okay, and the protection. The withdraw method contains built-in rules logic that checks if we have sufficient funds before updating the database. The withdraw method, this method, okay, contains built-in rules, okay, that checks if a sufficient fund is there or not for updating the database. Okay, for updating means account, here updating the bank account. So if we want to withdraw more value than the bank account holds, then it will give an error. Okay, you didn't have sufficient funds in the account, like that. Okay, that's the rules which is contained by withdraw methods. And then here I have written object based data model, some points and then example is there. So now in the data object based data model is the database model that stores data as objects instead of tables, and it combines the features of object oriented programming with the core functions of a relational database. We have seen the features of object oriented programming, and then we will see the core functions of a relational database. Here they are. So, core functions of relational data model. Data definition: defining table, views, indices and relationships for database schema, means database structure. And data manipulation and querying: inserting, deleting, updating, retrieving data. And data integrity constraints: ensuring accuracy and reliability of data using strict rules like primary key and origin key. And then transaction management, ACID properties, guarantees that multiple database operations are processed reliably via the ACID model. And concurrency control, manages transaction operations effectively. Transactions means the step-by-step operations performed on data items, as I have earlier said, example also for this. And then security and access control, handles user authentication and authorization. And backup and recovery, provides mechanism to take regular snapshots of the database state. Snapshot means copies of the database. If a person modified the database today, then we don't need the modified database, we need the original database. So we can backup it by using these copies. Okay. So here object oriented programming language features are combined with the core functions of a relational database. As we have seen, for all features of object oriented programming language, I have said one example. For abstraction also, for external view, a conceptual and physical view, for each level, so I have explained the example. So which tells that and I have given polymorphism example also, like accounts. And then so these examples shows that how the object oriented programming language features are related to core functions of the relational database. Okay. And then we will see the object based data model. So here in this, some important points are there. So first is class, a blueprint or template for creating objects. And attribute, the properties that describes an object. Example, student, if a student is an entity, then attributes are student name, student ID, etc. And methods, the operations or behaviors that can be performed by the object. Example, calculate calculate GPA or update address. Okay. And this is in the student entity, and this is in the customer entity. Okay. University example is university database that needs to track students and professors. Okay. And instead of using separate rows in multiple tables, we define them as objects. So person class is the base class. Attributes are name, address, date of birth. Student class inherits from person. This is the subclass means, and this is the superclass. And attributes inherits name and address, add its own student ID and course. Methods enroll in course parenthesis pay tuition course. And professor class inherits from person. So professor class is also a subclass, inherits from person. Attributes inherits name and address, add its own employee ID and department. And methods are grade student parenthesis conducts research parenthesis. So related SQL code will be like this: base class person. Okay, this is in the comment line. So, and we are creating a table person, create table, table name is person, and product ID one column, and domain is int, primary key, it's a primary key. Auto increment, name varchar of 100, name is another column name, and varchar is a data type, not null. The column must be not null. And address varchar 225, and date of birth date. And then inherits from persons, this student table. Okay, create table, table name is student, and person ID int primary key, and student ID varchar of 20, unique not null, and course varchar of 100 semicolon. And for region key comma. Okay, for region key person ID references persons of person ID on delete cascade. Okay, semicolon. Then inherits from person professor. Create table professor, table name is professor, person ID into primary key, employee ID varchar of 20, unique not null, department varchar of 100, for region key person ID references persons of person ID on delete cascade. So here in this code, inheritance is there. The students and professors tables use person ID as both their primary key and a for region key. In this student table and the professor table stores the person ID of the person table as their primary key. Okay, and as their for region key. Okay, this ensures a one-to-one relationship between the subclass and the base class. So one-to-one relationship means what? One occurrence of A is related to one occurrence of B, and reverse. One occurrence of B is only related to one occurrence of A. So here the person ID is unique for all the students and for all the professors. So here we are creating one-to-one relationship. That's why. Means one each id is related to is means specified to only one student, and that student is exactly have only that person id. And in the professor case also same, one person id is specified to one professor, and that professor only considered for those for that particular person id. That's the meaning of one-to-one relationship. Okay, primary key, it is not unique, that's why we are making primary key. The person id we are making primary key, because primary key does not have any, primary key column does not have any duplicate values. Through which each person id is assigned to each student and each professor in the student table and in the professor table respectively. And then shared attributes, data like name and address are stored only once in the persons table to avoid redundancy. Shared attribute, data like name and address are stored only once in the persons table to avoid redundancy. Here in the persons table, name and address are only stored once. Okay. So here from the this table, student table and the professor table are using name and address, and here also name and address. Student table and professor tables are using name and address columns of the persons table by using this specific person id. Okay, as a for region key they have included in the tables. Okay, so that they are access to name and address columns. And then specific attribute, unique fields like course id, departments are kept in their respective specialized tables. Here in the student table, course id is there, and in the professor table department is there, and employee id are unique column names. Okay, which are not present in the persons table. And in the student table, course id and student id are unique column names which are not in the persons table. That's the meaning of this statement. Okay, and then data integrity, the on delete cascade ensures that if a record is deleted from the persons table, the corresponding student or professor record is also removed. In this so in the persons table, if a record is deleted, then student table and persons table also delete that same record. Okay, because they are related, these three tables are related to each other through primary keys and for region keys. All mapping coordinates are accepted by the object based data model. means one to one, one to many, and many to one, and many to many, all cardinalities. Okay, and then here is the query example. So the query is, we want to display the, here is the table. Okay, first is see the tables. First we are seeing the tables. Persons table, person ID, name, address, date of birth, 1 2 3 and ABC, Bob, DR, 1 2 3 Pine, 4 5 6 Oak, and 4 6 5 RD are addresses, and date of birth 2002 5 14 2001 9 22 1975 11 3. And student table, it has student ID, course 1 2 and CSC and maths. Professor table, employee ID and department, only one row, 3 engineering. So here we want to we are joining two tables. Okay, here we are in this query, we are joining two tables, that is student table and the person table. Person table and student table, we are joining it. Here in the query, from persons P, inner join students S on P dot person ID is equals to S dot student ID. Means we are adding two tables at person ID and student ID, because these are same, person ID and student ID are same. See 1 and 2, here also 1 and 2. To join two tables, we need the same column with means same column values, okay, in both tables to join it. Okay, here P and S are user defined, okay, words or alphabets, we can say. P is used for person and S is used for student tables. So here in the student ID, so here first select P dot person ID as student dot ID semicolon. We are combining these two columns, this person ID and student ID, and we are making person ID as student ID using as alias. Using as alias, we are changing person ID to student ID. Column name, okay, here it is student ID 1 and 2, and P dot name, P dot address, P dot date of birth, and S dot codes. P dot name, P dot name, P dot address, P dot date of birth, and S dot codes. We are accessing all columns, okay. In this also one course ID, course name, okay, course name is there. So we got all columns, so okay. We are using one user defined word for a particular table, which is person table, that is P, and we are accessing with the help of dot operator the columns, okay. And for other table, for student table, we are using new user defined alphabet, and by using dot operator we are accessing their columns, okay, and then we are joining it. at person ID and student, because person ID and student ID are same. It will show 2 columns only, 1 and 2, because the student table contains only 2 rows. Even it has 3 rows, but student table has 2 rows only. That's why it is giving 2 rows only. All values it will be show: A, B, Bob, 1, 2, 3, Pine, 4, 5, 6, Oak, 2002, 5, 14, 2001, 9, 22. All values it will be displayed here. So this is the query. Means the query is joining 2 tables at IDs and with all details of person IDs 1 and 2, means name detail, address detail and date of birth detail. Okay, so that's it for today's class. Hope you understand this video and concept. If you feel this video is helpful, then like, subscribe, share and comment also. And if you have any doubt, ask me in the comment section. I will see you in the next class. Thank you. Bye.